Okay, so Rafa, everybody, just to introduce you a little bit to who he is. He's actually one of our co-organizers at the Angular Community Meetup. We really loved working with him there, but we really got to know him because he's just he loves Angular and he's such a dedicated programmer and so impressive. I think first time we met was probably at ng-conf, or at least
Yeah.
yeah, something like that. And anyway, he's really put himself out there, built a great reputation. He speaks at events all over, and he's become an Angular GDE. So excited to have him. And then currently, and you'd have to tell me if your title has changed, but last I heard you were a senior engineer with Hero Devs. Is that still
Yeah, that's still accurate. Yep.
perfect? So, okay, well then, yeah, I'll just turn it over to you and excited to learn more about component testing.
Sweet. Thanks, Brooke. Thanks, Chris, for the opportunity. Happy, excited, nervous to be here. Um, yeah, my name is Rafael Mestre. I am from Puerto Rico. I'm an Angular GTE, and I'm a senior software engineer at Hero Devs. Let me share my screen. This workshop is going to be a little bit unstructured. If if at any point we will be stopping for questions, but you want to, well, I can switch things up. We need to go faster, go slower, uh, more difficult, simpler. Let's work together and make this thing work for everyone. Uh, when it comes to testing, you've probably all heard about or seen this testing pyramid, right? Um, there's unit tests, which is the most basic form, the simplest type of test. There's integration test, which is kind of a sweet spot in the middle of interacting, of verifying interactions between different units or different components. And then there's end-to-end test, which tests the entire application as it runs in a real environment. I personally prefer end-to-end tests. I think I get most value out of those. They do test everything holistically, a cohesive form of testing and more realistic expectations, if you will. Uh, but they're usually off limits for many reasons. People prefer or at least select unit tests, maybe because of business restrictions, time, experience. So unit tests tend to be the most commonly used.
Hey, Rafa.
Um,
Real quick, were you wanting to, do you have like a slide that you were sharing or the code?
no, I don't.
Oh, okay. I just want to make sure.
So
Thanks.
yeah, no, right now I'm sharing my screen. I'm just kind of setting the stage. So this is going to be what I'm going to be working off of. So yeah, we are going to be talking about component tests, and component tests are unit tests because a component is a unit. And we're going to kind of talk about what that means, maybe clear up some misconceptions, some common issues when we talk about unit tests or when we talk about component tests specifically in Angular. And I'm also going to try to talk about concepts more generally, so not necessarily Angular specific details, but concepts that can be applicable to anywhere that you write tests, whether it's unit test, end-to-end test, Angular, React, whatever it is. So we're going to cover what to test, what not to test. I'm going to focus on human-centric testing and why that's important to me and how I write tests. We're going to talk about some patterns, some anti-patterns, and how to avoid those last ones. And since we're using Angular, we're going to be using TestVed. I've heard opinions about TestVed. I know some people don't like TestVed. I think it's very, very important to how we test in Angular. I think one of the common approaches I've seen is that we treat a component as a class, and we'll do something like a component, new counter component, and just instantiate it and interact with it, test it that way. I think that's rather limiting because it's not the reality of how we interact with a component. A component is a DOM element, not a JavaScript class. So testbed gives us the power to test it it's sort of a platform to emulate the Angular runtime, right? So you think the testbed is important. And even if you're using another framework, which we're going to be introducing in a minute, we're going to be using Angular testing library. But if you're using that or you're using Spectator, note that under the hood, it's all testbed. And testbed has kind of a bad rap for being slow, but I don't think that's the case. Well, let me preface by saying I think any hit to performance is offset by the benefit that you get from going through testbed. And in a lot of cases, the overhead is actually something else. Like Jest is kind of slow. If you're using NX and you're caching, it adds a bit of overhead. If you're using testing library, even that obviously has its own layer that needs to be interpreted and slows things down a bit. But as a general rule, I use testbed to ensure that we are testing our components properly. So this is like a basic setup, something out of the box. We have testbed, configuring, importing our component, compiling it, providing a fixture. So let's set the stage first to start using Angular testing library. I'm going to go ahead and remove this second test first. I'm going to remove this smoke test, and I'm going to remove hook even. And I'm going to introduce testing library by using the render method. Let's await render counter component. And so this looks really nice. It's a simpler API than testbed, but keep in mind that under the hood, it's all testbed. One of the main goals of the guiding principles for testing library is testing as an application or as a component is actually used. And we're going to be introducing that little by little. And there's also the option of using Spectator. I think Spectator is great. I've been using it in a project recently. And it's very good. It's very powerful. It's probably more robust than Angular's testing library, but that comes with trade-offs because part of the goals of testing library is to make sure that you're only testing the things they want you to test. So we replace this testbed call with testing libraries render. We're going to go ahead and replace some other things too. I don't want to type that out because I have a friend that types them for me. And so we can focus on the details. Let's go ahead and read this out. It should start with a count at 0. Render counter component. Our heading is in the screen, which we get by role. We find a heading with the name of count, and we expect the heading to have a text content of count:0. So let's talk about human-centric testing line by line. First, we have our test case. Our test case says should start with count at 0. That's very understandable, very easy to parse mentally. You could also type something like should initialize the count signal at 0, which still makes sense. It still does say what test is doing, but it's not really human-centric. And if we're sharing this output with someone non-technical, then should initialize the count signal doesn't really read as human-friendly. So I prefer this type of statement whenever I'm writing a test. So I avoid terminology like saying flags or inputs, or I try to use abstract concepts as much as I can. It's not always possible, but just as a rule of thumb. Same thing with this statement, render a component. Easy, simple. There's a lot going on here, so let's break it down. Screen, get by role, heading with the name count. Okay. So another principle of human interaction testing is that you test as if you were a user. So we're not going to say document query selector and we're going to look at an element. We're going to talk to the screen. We're going to look at the screen and we're going to find a heading with the name of count. The specifics of what we pick to put in here don't really matter. There are two main goals. One of the main goals is that, again, it acts as if you're looking at the screen and you're identifying something visually. And the fact that you can change your tests without the risk of breaking if we're using broader concepts like this, such as heading. So this is currently passing, and if I change this to an H1, it's still going to pass because it's just looking for a heading with the name of count. Whoops, I changed the wrong one actually, but it will still work. And finally, we have our assertion, which reads really nicely as well. Expect heading to have text content count :0. Pretty self-explanatory. And this is essentially the same as if we did expect heading.text content to contain count :0. But this one is nicer to read. Now, this isn't a native jest matcher. This is a custom matcher that's provided by testing library. And Spectator does the same thing if that's what you're using. The goal here is to, again, feed into the guiding principles of human-centric testing where you're reading things out loud and it works the same way. It reads just as it executes. Expect heading to have text content, even if under the hood it's doing exactly the same thing. So we kind of set the stage here with how we're going to be structuring our tests, how we write them, and a couple of tools that would get you ahead and help make things easier. Now let's talk about what to actually test in a component. Let's move some things out of the way. So usually, I've reiterated a couple of times that we're testing as a user. So as a user, what do? I look at the screen, I click on things, and that's how we want to test. Here again is an illustration of that. This is a setup. This is looking at the screen. This is checking that the screen has what I need. So as far as the public API of the component goes, we're going to test the input. Let's go ahead and switch over here where I have some tests that are already set up. And let's look at the input. This is a pretty similar test. The render function of testing library has a simple API that lets you override everything that the test bed will let you override. But since we're kind of just interfacing with the public APIs, we want to keep it purposely shallow. So our inputs are going to be the max value of 5, just to make sure that we have something different than the default value so that we can assert that when looking at the heading, the text content is 5. So that should work as expected. All good. So again, we are testing the input as a developer public API, and we are asserting the text content, so we're looking at the DOM. Note that we're not at any point looking at the value of the input itself. We're not asserting that increment has been called. We're not asserting that decrement has been called. We're just saying we think this number should be here. Is it? And that's all we want. Everything else in between is, I consider, a test of an implementation detail. So that's not what we want to do in this paradigm of testing. We also want to test output changes. So this is a little bit different. We do want to provide a SPI because there's really no way around this. And we test this as part of the developer's public API. The developer technically doesn't need to look at this. The public API is when you put a selector in a component and you see what inputs there are, what outputs there are, and that's the public API. So we still do test this output. What do? We set it up, we pass in a SPY so that we can assert that it's been called. We look at the screen and find the increment button, click it, and expect that it's called. So we're not looking at any of this at any point. We're not saying expect increment to have been called, expect decrement to have been called. And we're certainly not interacting with the methods directly. So let's introduce an anti-pattern now. I can rewrite this test, and instead of doing this, I could do, let me turn this thing off for a second. We could say, let's expose the component. It's a fixture, component instance, increment, and call it. We've all done this before, but this is inherently testing implementation details. If you find yourself using bracket notation like this to pull to look into something that's private or protected, there's probably a better way to do it. If you're casting as any, so you can do something like this. That's probably bad too. And it's just as bad if you are removing this and making it public just for the sake of testing. Again, it's not the end of the world. I've had to do it all the time. But the correct mindset is a component, a service, or anything of the sort is going to have a public API. And if the user can increment that counter by clicking around on the DOM, then so can a test. So let's bring back the code here. And you'll notice that in most cases, you do have, the render function does return the fixture and all the stuff you're used to if you're using testbed or anything of the sort. But generally, I'm avoiding it because we don't want to touch the component instance, or at least not as much. So in most cases, you're going to see that we just await render and ignore the result of that because we shouldn't care. We just set up the component and then have the user interact. We can also assert other types of scenarios, like this is a conditional element here, so that we can say it should show a warning when the count exceeds the max value. We set the max value to something low, like here it's just 1. We click the button twice so that it's over the max value, and then we just say, look at the screen, find a warning element, and expect the warning element to be in the document. So if this doesn't increase past that threshold, then it's going to fail because it shouldn't be visible. And that's the type of assertion we want to make. We want to say, I click this button, or the user clicked this button. Is the expected outcome there? Can I see a change in the DOM? This is a pretty similar test. We're just checking that. We're just increasing coverage in this case. We're saying we tested if an output changes. We tested the max value. We tested if an optional element is showing up. And we're testing that when you click the increment button, the count increases. So we have human-centric tests defined as such. And we're at no point we're interacting with the component instance. We're not interacting with private methods. So everything is about how the user sees it, or how you see it on the computer screen. So what else is fair game that you would consider part of a component test? I have another example here. This one may be kind of an opinionated take, but I think that you can have presentational components without using just inputs and outputs. So here I have a component with a very similar API as the other one. It has an increment, it has decrement, it has count, but it's behind a service. This service represents whatever you want it to be. It could be a component store, it could just be a facade, it could be a plain old service with a subject or something like that. But it has pretty much the same API. I think this is a valid use case for a presentational component because the surface is small. It just injects the service and interacts with a couple things. So what do you do in this case? In this case, the tests look pretty similar. Here, I am looking into the fixture to get a service, spy on the save, and making sure that when the user clicks on the button, save is called. We can rework this a little bit so that we don't have to look into the component instance like that. We can just say we have a save spy, and we can provide our service directly. And I think this is a fair way, even though we have a component that has a service, you're testing the component and you're testing the least surface of the service that you can. So create the thing, look at the screen, click save, and make sure that the service thing was called. Nothing else really matters in here. I think I need to mock the rest of the methods, don't I? Yeah. So here, let's create list mocks for everything. Oh, here I need to use, because the service is provided at the component level, I need to use component providers. There we go. All right, cool. So we've covered the basics of what we test in a component. We've covered testing with a service. We've covered how to transitively test what's public. Do we want to take a pause now, maybe to answer some questions, interact with the chat?
Yeah, there was
Fine.
one thing that was just brought up in the chat about good suggested approach to convince the team about the benefits of implementing a library such as testing library. So I guess like what benefits do you get out of that versus just test bed?
Yeah. So this is something I'm actually going to explore in the future, in a future talking point, but just to kind of start setting the stage for that as well. I think it's useful for two reasons. One of the reasons is that the simpler it is to write your test, the easier it is to write your test, the more tests you're likely to write. So we're going to talk about another type of abstraction layer that I commonly use to make that so. But yeah, aside from having a simpler API that will make it more likely for you to write more tests, it also makes it purposely obfuscated to do the wrong thing. So like, yeah, you can probably expose the fixture and do stuff, and you can probably do like query selector and test the old-fashioned way. But at least for a library like Angular testing library, the goal is that the API surface is small, it's shallow, so that you kind of try to seek out these solutions first. How can I test the DOM? How can I make sure that this is being tested as a user? I think, yeah, that's pretty much the main goal, like the main guiding concept. I'm going to share some resources later, but Angular testing library does have like some guiding principles where they talk about that, like only test certain things. In fact, I'm gonna drop this in the chat. We can continue anyway, but That's one of the guiding principles of testing library. So yeah, to me, it makes it more likely to write correct tests because it has a shallow surface, and it also simplifies the API, so it makes it more likely that you write more tests, which is good. And we're going to see in the later on how we can do even more of that.
Great. Thank you. Yeah, I don't see any other questions in chat. I think you're explaining things so well. Everybody's getting it.
Awesome. All right. So let me peek at my notes real quick. So yeah, for the most part, we focus like on DOM interaction and how the user sees it, right? And I like to keep that in mind also when not just how we test per se, because the contents of the test are one thing, but how we write our test case statement and how we write our assertions is also important, because someone else who is not a developer could be looking at this and say, hey, I looked at your components test cases, and I think we should add a test case that does this thing. And that's very valuable. That has strong business value to say, I think this should probably cover negative numbers. We don't want to have negative counts, so maybe we need to add that in. And so by making it human-centric, we include more people in the conversation. One more thing to when we talk about implementation details and whether we test them or not, if we have a component that has a child component has a dependency, and that dependency has another dependency. Oops. How do we test it? So if we just take a very basic scenario, like any other component that we've tested so far, we just say should be in the document. We're looking at the screen, expect the heading to be in the document. Perfect. So we run this and it's not going to pass. Why not? We don't have a provider for HTTP client. Okay, that's easy, right? We just provide HTTP client and it works. However, this is treading into the realm of integration tests. It's not necessarily a bad thing. You could leave this here. The test passes, so that line tends to be blurry. I've seen lots of cases where you're writing a unit test and it kind of feels like an integration test, and it's up to you to draw those lines. But offhand, I think this is probably not correct. So what's the alternative? The alternative is to mock out the component. Component imports. Let me silence this thing again. And instead of providing the HTTP client, I'm going to use ng-mocks. And I'm going to mock the component so that it's removed. It's replaced with a dummy. And so now we don't need to care about this transitive dependency or the HTTP client or anything of the sort, because this is just going to replace the element in the DOM with a plain old child component tag. It's not going to replace the value with the real component. If the component didn't have that service, maybe in that scenario it's fine, because you're not really testing anything of consequence. So in that case, if you just want to leave the component to render in the parent, it's perfectly fine as well. By the way, I turned off the AI thing because I don't want it to get in the way of the workshop. But if you're not using AI, start using AI. Okay, last but not least, let's go into one of my favorite patterns lately. I didn't use this before, but since I learned it, I think it provides a lot of benefits that compound on top of the stuff that we discussed before. One issue with with things like testbed, sorry, I have to fall back to testbed to make this look worse than it actually is in this case. Okay, so generally we use block level variables like this. We use hooks like before each and after each. But those are sometimes prone to issues or easy to have some global state left over. Even if you don't think so, this type of this block level scope kind of becomes global state for all of the functions. And I've seen lots of false negatives or false positives brought on by something like a mock that's declared here and it was never reset. Yeah, you could just do after each and then just reset all mocks or clear all mocks. I don't remember which one it is, but yeah, you can do that and try to ensure, but you have all of these edge cases. Sometimes there's other types of things that you need to reset. And I like this pattern because it adds to that, and it also adds to the other point we talked about before of writing many tests. This pattern, where instead of using hooks, you use a setup function that returns everything you want to have in a test, is called Ciphers. Ciphers stands for simple injectable functions. I forgot what the E stands for. Returning state. Simple injectable functions. Something returning state. What that means is that we don't have any block level statements. We don't have any before each, after each. This makes our test even more deterministic because everything is mocked in here. Like including this, for example, we have a mock that's set up as a default value for our setup function. And we have more control of what gets reset, what's created from scratch. And we also get to clean up our test a little bit more. In some cases, it's not going to seem like much. Here, all of this one replaces is something like render component. That's all this replaces. But in other cases where we're doing more advanced things like, let me put the other one side by side actually. So we, in this case, it's going to seem like a bit trivial. It's going to seem like it doesn't add a lot of value because these are inherently very simple tests. But it compounds, it adds up. So here we abstracted the setup of every single thing that's in our test suite into that setup function. We added default values for max value for our just function. We passed in all the inputs and outputs, whether we need them or not, and then we just return stuff nicely wrapped. And if we compare each of the tests side by side, here we don't replace much, but it still looks slightly cleaner. Here we got rid of all of this and we just say setup with a max value of 5. Same thing in this next test. We don't have to declare, well, we do have to pass in our spy, but we do save a couple of lines of code there. And you can even take it a step further. If you want to abstract all of your queries, screen queries, you could put all of the screen queries inside of your setup function and return only what you need. By cleaning up tests and putting everything in one place, you not only make your tests easier to change, because if I name this something other than increment, instead of fixing it in both tests, I only have to fix it in one. It also makes it more likely, for all the same reasons I mentioned before, for you to want to write more tests. And wanting to write more tests is a good thing because I don't know if you've written one, but I've seen test cases where a single one could have 40, 50 lines of code because you need to mock a bunch of things and you need to force change detection and you need to pass an input and you also need to mock something in NGRX. It compounds, it adds up. And when we want to test multiple scenarios because we have complex logic and we have branching code, the easier our test suite makes it to change things around, the more likely we'll be to want to add more coverage. So In this case, it seems pretty simple, but in more involved cases, you see the value in that you don't you get to write more tests. If you had tests like this, if every single test in your suite that looks something like this, just 3 lines of code, wouldn't you be more likely to write more tests? And so even though something like coverage by lines or by branches, I don't believe in that stuff. I believe in business use case coverage. And so if you have a simple surface and you can write many, many, many tests just by changing some variables around, it makes it more likely for you to have better coverage. It makes you want to write more tests for that suite. I've used this in my project to great success when the setup functions are strongly abstracted and everything has to go through it. It makes testing a breeze. You can probably achieve this using hooks, and it's not that bad. You probably end up with a couple more lines of code, but as a principle, either approach. One of the things I keep in mind is this type of pattern of making it easy to write more unit tests. And that comes in more forms. For example, if you want to write custom matchers for your project, that's also a good idea. Jest has some pretty good documentation of how you can write your own matchers. A matcher can just be a wrapper on top of another matcher. You could just move some things around and then pass in whatever you want to call yours and extend Jest like that. So yeah, ciphers. It's a pretty cool pattern that will make you want to write more tests, will make it easier for you to do so. And before I forget, you also have the option of doing something like this, where if you have a describe block that has more complicated setup, you can pass that in. Sorry, you can extend the root setup, if you will, and return another local setup with like some default values. And that makes nested describes or other blocks of testing easier to want to work with as well. Yeah, so I think that covers everything. Let's take more questions if we have any.
Yeah, one person asked if they could see the setup method again.
Yeah, sure. Let me increase the size on this just in case. Yeah. So essentially, it's abstracting away the stuff that you would manually do in the rest of your test suites. Like here, for example, I don't care about the max value, the input, but we still keep that already set up for when we do need it. And you can have a very basic setup function that doesn't have any of this, and then you progressively add to it and add default values using default params or some other method if you want to keep this out or something like that.
Yeah, thank you. I don't see any other questions. If anybody had anything, feel free to raise your hand or put it in chat or the Q&A.
All right. Well, thank you so much again for having me. I see another question. I just started my statement. I'll get back to it in a sec. If you need to reach out on my socials, I will leave them in the chat. Also, if there's other topics that you'd like to see at some point, like maybe some more advanced testing or services or NGRX or something like that, hit us up, let us know, and we'll try to make it happen. I'm going to go back to a couple of the questions that are coming up here. I'm fairly new to testing and just trying to learn Jest. Do you exclusively use testing library or do you sometimes use Jest? Yeah, I have plenty of projects where just use plain Jest. I will say though that right now it's important to keep an eye on the ecosystem because Jest is kind of falling out of favor. most new projects are picking up v-test now. It doesn't really matter much in the grand scheme of things because the way that you interact with things, the API surface is pretty stable. They're pretty similar. But to answer your question more specifically, yes, there's still value in learning how Jest specifically works. There's a lot of things that an abstraction like this won't surface, like, for example, when you need to interact with more Angular specific mechanisms like overriding. Yeah, unfortunately. And when it comes to things like interacting with the clock, there's some things that Jest does, like mocking the timers or advancing the time. So even though we're using an abstraction and we want to try to keep it as simple as possible, yes, there's still value in learning Jest. And even if what I said pans out and we pivot to a new framework soon, most of the skills are going to be transferable. They'll just be like maybe a small syntax change or stuff like that. Also, v-test is very, very much faster than Jest, so there's that. Can you show all dependencies used in the package JSON? Yep. Close this out. So side dependencies are ng-mocks, which is it has a lot of utils, but what we covered here was replacing a child components with plain mocks, but it has utilities for services and every other thing you can think of in Angular. I will provide a link for that as well. And then everything else is related to testing library and the Angular preset for Jest. But those things are kind of done for you when you add testing library to the project. So you just install the one thing and it adds everything else except ng-mocks.